In this class, we were tasked with designing and 3D printing a prosthetic foot for a 22-year-old man with a right transtibial amputation. We needed to create something simple yet durable for his everyday activities. Initially, we knew we wanted to include cheetah flex into our design for force impact and articulating pieces to reduce stress and increase motion in the sagittal plane. I'm going to refer to the piece on the left as a foot shell, the top right piece as the ankle, and the bottom right piece as the sole.
With our first print, our biggest problems came from unintended scaling, incorrect tolerancing, and not having the heel extrusion in the foot shell extend far enough towards the metatarsal region. The first force test proved that including the cheetah flex print was extremely useful.
However, when the wearer walked in our foot, the PLA pieces slid out of the foot shell almost immediately. There was excess movement in the front and sagittal planes in the heel and where the articulating pieces touched, and the PLA broke off around the bolt on the sole.
In order to correct this, we added pop-in connector pieces in the heel area to ensure the PLA pieces moved with the foot shell and extended the heel extrusion to prevent the ankle from sliding forward. We also decided to remove the majority of the walls on the foot shell and decrease the thickness of the sole in certain areas as they were deemed unnecessary.
The pop-in connectors were very successful in preventing our foot from dismantling, but due to printer issues and thin walls surrounding the heel, the back of the foot shell sheared apart. A piece of the sole cracked off where it was in contact with the ankle during terminal stance. Our wearer also gave us feedback that there was still too much movement for comfort in the heel's sagittal plane.
For our final design, we decided to decrease the height of the foot shell's heel by almost half to allow for more control and comfort. We adjusted the sole accordingly and were able to leave the ankle piece unchanged. We also increased the height of the heel's walls for strength and decreased the size of the toe overhang for greater ease while printing.
These changes were extremely successful and accomplished our goals by giving our wearer more control, comfort, and safety while walking. Unfortunately, one of the downsides of 3D printing is the increased chance of shear failure. This occurred during the wearer's toe off. Luckily, the failure wasn't completely catastrophic as our wearer was still able to walk on it. There is still a lot of room for improvement on this design, but we have made a huge step towards the future of additive manufacturing.